Hello everyone, welcome back. Welcome back to the Technology Innovation Hub. It's going to be the eighth session on achieving greater career heights. Let me share the screen. We were just studying on the last slide actually on brain development architecture and how it affects to our career from the childhood, right? So that is what we were studying, and we completed these things. And yeah, the last thing that I was telling about the genes and the environment, the Harvard University references, right? Let's go there. All right, so I said I'll play one of these videos. Rest of you can play later and play by your own and learn those. Let me play the very first one. The science of adult capability. Just watch and listen carefully. Right?
Building core capabilities for life. Every day we take on the ordinary, sometimes challenging tasks of work, school, parenting, relationships, and just managing our busy lives. How do we navigate these tasks successfully? And what can send us off course? Science offers an explanation. We all need a set of core capabilities that we can develop with practice over time. Scientists call them executive function or self-regulation skills, and they help us to focus on what's important, to plan ahead, set goals, and meet them. They help us deal with whatever life throws at us and still keep heading where we need to go. They help us resist impulsive behaviors.
Stop.
And change course when we need to. No one is born with executive function skills, but everyone can build them. We build them through a lifetime of making connections within and among the regions of the brain. Our brains begin life with billions of neurons, rapidly connecting to each other as we experience the world around us, making trillions of connections in just a few years. Early simple circuits form a foundation that more complex circuits and skills build on as we grow and have new experiences. These complex circuits, built throughout childhood and reaching across vast regions of the brain, make our core capabilities possible. The more we use these connections, the stronger and faster they become. That's why practice is so important. When we are children, we practice these skills by playing games, learning teamwork, adjusting to new rules. We continue to develop these skills in adolescence by managing school and other things like work, sports, music, and relationships. When we practice executive function skills, circuits rapidly connect the prefrontal cortex to other parts of the brain. These circuits act like an air traffic control system in the brain. They manage incoming information and help us respond with intention, not on impulse. Threatening or stressful experiences activate different circuits, and those trigger automatic responses. Fight, flight, or freeze. We need automatic responses for survival, but if stress is constant, these automatic fight or flight circuits become stronger and faster than our more productive intentional circuits, the ones we use for executive function and self-regulation. For anyone under stress, it's hard to call on intentional skills. If we've been experiencing serious stress from our earliest years, the stress caused by poverty, violence, or addiction, a chaotic environment, it's even harder. Under lots of stress every day, it's harder still. The key is counterbalancing those automatic responses by building up our intentional ones, by building strong executive function skills. The good news is these core capabilities can be strengthened. How? By redesigning our systems so they reduce the sources of stress in people's lives, by simplifying how services are provided to families, helping them meet basic needs and building on strengths. Because small successes lead to bigger ones. With less stress, we can practice the skills we already have and build new circuits for the intentional responses we need. Stronger brain circuits are built through practice in situations that matter. That's true for children, it's true for adolescents, and it's true for adults. Helping children build skills gives them a strong foundation for all that comes later. Helping teens build their skills propels them into greater success as adults and parents. And helping adult caregivers build their core capabilities ensures success at work, stable homes, and responsive relationships for the next generation. When our communities work together to help children and adults build these skills, we create a positive cycle as one generation passes them on to the next. And that helps us all.
All right, you watched that from Harvard University Center on Developing the Center on the Developing Child, right? Center on the Developing Child, right? Okay, it comes under deep dives, right? So this website. Yeah, so it's like summarizes what we have been learning up to now. But just watch this stuff as well, very important. You can understand and grade the detail so that those things are really helpful for building a great career, especially this neglect, right? So those are the what happens at the early ages when a child demands. If you refuses in a hard way, harsh way, we learn those things, right? And it's just this the toxic, right? So toxic cause the stress, so those are badly affecting the brain circuit. And mental health, very important, just watch these things, right? Okay, let's get back. I'll get to the last one here. I have one more thing, the genetic brain. That's going to be the last one on brain development that we are going to learn, how the brain development and early childhood affects lifelong careers. That is the genetic brain. So let's take a look at this link as well, the genetic brain. This time it is from University of Cambridge, Cambridge University. These are research outcomes. That is again the genetic brain. But we have learned up to now, it explains in detail, right? So for example, there's been a research done using rats and chimpanzees, right? Because, you know, right, what they're telling is, you can see even in the first line, 99% of the mouse genes match the sequence of human genome. Now, you know this term, very, very, you can understand. You know what is a genome now, right? Right, set of genes, you can say, right, belongs to a species, right? So, all right, so we know human genome. I think we just go back and recall that just for you to go back and recall our terminology. So you get genome. You see genome, right? A complete set of genetic information in an organism. So now here they're talking about a genome, then you should recall the terminology at once. This is what we learned. Let's go back to our explanation. So what they're telling here, 99% of the 99% of mouse genes match sequence in human genome. If 99% is matching, it's like there can be only one difference, 1% of difference between the human and rats, right? Is that so? Right. So no, that's not the case, right? So now we know. Now we know it's not only about genes. There are many other factors like epigenome, epigenetics. So now those knowledge is there. So that's why genes may have. We know what genes does now, right? But the behavior, the expression of the genes outside is being controlled by other factors. So that is what we have to learn. here it says studies of animal behavior have shown that the offspring of a mother with good nurturing skills are more likely to be good parents themselves. As I think we learned something called serve and return. There was a video on serve and return. The things that you gave that you are going to return. Like this is another example. I mean, there are videos. I don't need to repeat those things. This is something. I mean, if you become a good mother for your child, definitely in the future, that child, when she grows, she can become a good mother for her child. That's what it says, right? Very clear. So this is again from Cambridge Neuroscience article. Now I don't need to go through this document. So I have the takeaway from the document given here. So let's go through that. In the slide, I have given the takeaway. So this is the takeaway from this document, right? So what is this? The first one. The genetic code of mice, chimpanzees, and human all share remarkable similarities. 99% of the mouse genes match the sequence in human genome. Right? So that's what I mentioned. We mentioned that one, right? Epigenetics is the study of how set of reversible, heritable changes in the functioning of a gene can occur without any alterations to the DNA sequence. You know that epigenetics is not going to alter the sequence, but it's going to change how the DNA works, right? The sequence is the same. We learn that on off of DNA's behaviors, and these changes may be induced spontaneously, right? These changes may be induced spontaneously in response to environmental factors or in response to the presence of particular gene, right? All right, so we have learned that. And studies of animal behavior have shown that the offspring of a mother with a good nurturing skills are more likely to be good parents themselves. That I just explained earlier. Since since most human brain development occurs postnatally, right? We know that, we learn it. First 3 years, very critical. Prenatal also some certain development happens, but postnatally, that means after birth, right? Postnatally, the brain more than any other organ is under strong social and environmental influences that can have long-lasting effects on brain function and well-being. Very important statement. This is there exactly in that document. So I'm just taking the summary. Since the most human brain development happen postnatally, understood, the brain more than any other organ is under strong social and environmental influences. Definitely, we have discussed this on the environmental effect for the brain, and it's taken by the epigenome and how it's going to change the behavior of the genes. So what it says, the brain more than any other organ is under strong social and environmental influences that can have long-lasting effects on brain functions and well-being. Exactly, right? Not like other organs, because brain is a root for everything, right? We know that. And I may remember one of the videos mentioned we learn about the brain from the brains we have, right? We learn about the brain again from the brains that we have. Okay, so it's a life. I mean, life. Long lasting, lifelong learning. So if you put the foundation properly in the early childhood development, you are going to have a lifelong, very good career and a very good learning experience, which is going to be a bright future for you, healthy, wealthy, brighter future. That is what, okay? All right, so that's going to end our this session in the one of the sessions actually in this series. Up to now, we have been discussing about the brain development. This is very, very critical, very, very important. Please revisit the videos and the video that I shared, and go to those sites, Howard University and I mean, Basisters, and again we had Cambridge, and there are other videos, right? So go to those sites, just listen and rewatch those things and get the knowledge. It will be very important. As a parent, it will be important for you. As an adult, it will be important for you. As a child, it will be important for you, right? Or whatever, whoever you are having a career, right? It will be important for everyone, right? So go through and visit. So next we have, still the series is not finished, right? Just one page is finished. It's a long series because it's going to cover the full career development for a intellectual. And the next in line what we have is this. How do we learn style one? Now we are going to talk about learning styles. Learning styles. Once the foundation is put, brain foundation is done, then comes the learning styles. Right? And the style number one is this. Style number one is going to be theory of multiple intelligence, Gardner. Gardner theory of multiple intelligence. Okay, so let's do that in the next session. I think since we have finished the brain development phase, so let's start the next session. How do we learn using learning styles? All right, I meet you soon. Have a great time. Bye bye.